My name is Nusrat Jung. I am an assistant professor at the Lyles School of Civil and Construction Engineering at Purdue University. People buy fragrance products, and it is because they like certain scents, and their intention is to recreate a scented environment. However, they are not aware that while creating this scented environment, they are also exposing themselves to a heavy dose of air pollution. So these wax smells are filled with fragrances, and while you are using them, the wax melts and then releases these fragrances into your indoor environment. These fragrances are heavily laden with different types of reactive chemicals. They can react within the indoor atmosphere to form secondary organic aerosols. The wax warmers generate large amounts of nanoparticles. They are almost as similar to that of a candle with combustion. So our finding is that flame-free candles are not pollution-free. Wax melts are producing similar or greater amount of fragrances in our indoor environments as that of hair care products, personal care products, disinfectants that you use for cleaning purposes, and so on. We spend 90% of our time in indoor environments. It's typically a building that is mechanically ventilated. When we introduce fragrance products into our indoor environment, they may linger around much, much longer than they would in outdoor environment. The natural next step would be to further understand and investigate the health effects of inhaling these secondary organic aerosols and what they may be. The concentrations of nanoparticles that are being released during use of these scented products is very high. It is imperative that we understand and further investigate what negative health effects these particles can cause. Welcome to Purdue's zEDGE test house. Today we are going to conduct an air pollution experiment in the test house. We are surrounded with very sophisticated instruments that are able to show us the composition of the air that is changing all the time. So here we have a wax warmer. We have a piece of heavily fragranced wax that is melting. And while this wax melts, we are recording with our instruments how the composition of air is changing. Right here, I have a Pegasaur instrument. This is measuring CO2, temperature, and relative humidity. Over here, I have a very interesting instrument that is able to measure particle number size distribution. We are able to measure particles from 6 nanometers to 10,000 nanometers. We also have another fascinating instrument right here. So here we are also able to see total volatile organic compounds. So the wax melt is releasing fragrance into the air, and we are able to see the composition of that air and how that is changing as well. Here we have an ozone analyzer, which is telling us about the amount of ozone that is naturally present in our indoor environment today. You can see the value is 16.1. What is so unique about it and why we are measuring it? Well, these fragrances that are being released into the air may contain multiple kinds of chemical compounds that are highly reactive. And over here, we have a very sophisticated mass spectrometer, which tells us more about the chemical speciation of the air second by second. So we are able to record in real time all the changes that are occurring in our indoor atmosphere just while this wax is melting.